My name is Christine, and for my hobby I'm playing a game where I choose an organism and improve the traits via mass selection. Under multiple collections listed, I'm going to go into the fruits collection and choose blueberries because I currently have a blueberry bush at my house where I'm currently stuck in. Some basic information is first given. Assuming the trait of producing fruit resembles a normal distribution, the mean of the original population is 5 pints, as shown by the pink line, and the standard deviation is 2 pints. The original population is shown as the pink curve, and the broad sense heritability and realized heritability are provided, which is 0.85 and 0.67 respectively. Taking this information, we can start the tasks. Task 1 is to find the selection truncation point. You first select blueberries to interbreed, so since I want to increase fruit production, I've selected the top 10%. The truncation point, or the point from where I select, can be calculated using the formula shown. Standardized selection point, or Z, for 10% is 1.282 as highlighted in the table. Plugging the numbers into the formula, the truncation point is 7.564 pints, and is labeled as T sub T in the graph in blue. Task 2 is to find the selection differential. The selection differential is the difference between the average of those selected and the average of the original population and can be found using the formula I times sigma. The selection intensity, or I, is 1.755 for 10% as shown in the table, and S equals 3.51 pints when you plug it into the formula. Using the selection differential, I can now find a mean of the individual selected to be parents, which is task 3. Rearranging the formula for selection differential, I get 8.51 pints to be the mean of the selected parents, labeled in green as x bar sub S. I can also now label the selection differential, or S, also in green. Task 4 is to find the response to selection, or R, which is how the population responds to the selection that I put them under, which can be found by this formula. Although we don't know the mean of the offspring, or x sub 1, we can figure out R by using the realized heritability, since it equals R divided by S. Rearranging the formula to solve for R, we have this formula, and by plugging in the values we know, we get R to be 2.3517 pints. The last task is to find the mean of the offspring, or x bar sub 1, by rearranging the formula from the previous task to get x bar sub 1 equals R plus x bar naught. Adding the values of R and the mean of the original population together, we get the mean of the offspring to be 7.3517 pints, labeled as x bar sub 1 in the graph in yellow, and the response to selection, or R, labeled in the graph as well. The mean of the offspring, or x bar sub 1, is 7.35 pints, and the progeny population is shown in the dotted yellow curve. While this is great and I could continue these mass selection experiments indefinitely, there are limitations, as in later rounds of selection, the amount of fruit produced would eventually decrease, as the amount of fruit a blueberry bush can have is limited, and as a result, having too much fruit will cause decreased vigor and productivity, resulting in decreased responses.